Welcome back. Today we're going to be working on proportionality day number 2. Our content objective is students will be able to solve proportions and word problems involving proportional situations. Our language objective is students will be able to explain in words the process of solving proportions. Why am I learning this? Well, it's important for many real-life problems like figuring out how much sugar is needed to make cookies. Taking a look at the first problem, it says what value must n be so that the two ratios are equivalent? Okay, so what we're trying to figure out, in a sense, is a constant multiplier. Like, for example, what is multiplied by 7 to give us 9? Okay, so since I don't know the number, let's pick a variable. Now, typically, I would think n for number, but I can't use that. Why? Because n is already used by something else. So let's go ahead and use, for example, m. Okay, so 7 times m somehow manages to become 9. So what is 7 being multiplied? Well, let's go ahead and rewrite it like so and solve for m. What number is being multiplied by 7? Well, I'm going to divide both sides by 7. And I'm going to find that 7 is being multiplied by 9/7. Now let's see, is that true? If I multiply this by 9/7, does it equal 9? The answer is yes. So in order for this to be equivalent to 5 must also be multiplied by 9/7. So to figure out n, I'm going to do 5 over 1 to make it into a fraction, times it by 9/7, and that's what's going to give me n. I can't cross reduce, so I am going to be left with 45/7 equals n. Okay, so what is the value of n? I would say the value of n is 45/7. Now, keep in mind that you can also turn that into a mixed number. I'm going to go ahead and leave it improper though. Okay, so some background knowledge. For some problems like this, you might be able to do it in your head. For example, how does 4 become 20? Well, I'm multiplying by 5. So then I can easily determine what n is, because if 4 is being multiplied by 5, this denominator 5 should also be multiplied by 5. So what is n? n is 5 times 5, so I would say n is 25. So here, I don't know how 32 became n because I don't know what n is. However, I do know how 120 became 60. Now, a lot of you would say, oh, we're dividing by 2, which is absolutely correct. But I do want to show you another method as well. You could think of it as multiplying by 1/2. Because if you multiply 120 by a half, you do get 60. It's another way of expressing the idea of dividing by 2. So if I'm multiplying this by a half, I'm multiplying 32 by a half as well. So what's n? It's going to be half of 32, so it's going to be 16. Okay? So coming back to this problem, we found out that we had to multiply 7 by 9/7, which means we had to multiply 5 by 9/7. So you'll find here that 9/7 is the multiplier. So when we went ahead and multiplied 5 by 9/7, we would find that n equals 6 3/7. Now, from the previous slide, I did leave my answer improper, which was 45/7. Understand these two are equivalent. They represent the same exact number. Okay? So if I were to go ahead and write this value in for n, this is what it would look like. Please understand this is also correct. 45/7 over 9. All that I did was took the value for n and substituted in for the actual variable here. Okay, so here, same instructions. It says what value must n be so that the two ratios are equivalent. So here I'm going to start with how did 4 become 21? So again, since I don't know what's being multiplied by 4 to give me 21, I'm going to go ahead and pick a variable. Now typically I would use n because it makes me think of a number. But again, it's already being used here, so I'm going to have to use something different. The last variable I used was m, so let's go ahead and be consistent and stay with that. So I'm going to do 4 times a number m is going to equal 21. So I'm going to go ahead and write that off to the side. 4m equals 21. This means 4 times m, so the inverse would be to divide both sides by 4. So I'm left with m equals 21/4. So I'm claiming that the multiplier is going to be 21/4. Let me go ahead and check this to see if it works out. The 4's cross cancel, leaving me with 21, so that's good. So I'm going to claim in order to find n, I'm also going to have to multiply by 21/4. So let me go ahead and work it out here. I'm going to put it as a fraction and multiply it by 21/4. I can't cross reduce, so I'm going to multiply straight across. Wait, this is going to equal n real quick. 5 times 21 is, let's see, 21 times 5. It's going to give me 105/4 equals n. So my value is going to be this here. So if I wanted to go ahead and write it, I'm going to leave it as 4/5. Oops. Try it again. 4/5 and 21 over, now instead of an n, I'm going to go ahead and write my value here, which is 105/4. Now you definitely could turn this into a mixed number, but I'm going to go ahead and leave it in proper just to save myself some time. So in this case, what was our multiplier? I would say the multiplier is our 21/4. Okay, so that's another important thing to keep in mind. What are the numbers changing by? What factor? In this case, it was 21/4. Now, by using that 21/4 as our multiplier, we created these two fractions, and these are now equivalent. And how did we know that? Well, because we purposely used the same multiplier for both to get the values here. So these are indeed equivalent. Moving on to number 2. The instructions are exactly the same. I need to find n so that the two ratios are equivalent. So here I'm not going to work with 9 and n since I don't know the value of n. So I'm going to go ahead and work with how does 2 become a 13. So it's being multiplied by some value. I'm going to go ahead and call it m like I did in the previous ones. So 2 times some value m is 13. So I'm going to go ahead and set it up as this equation here. 2m is 13. I'm going to solve for m, divide both sides by 2, and that's going to leave me 13 halves. So here I'm going to go ahead and claim that 2 is being multiplied by 13 halves. And let me just double check that this is true. So yes, that's what I'm going to claim is my multiplier. So let me just go ahead and write that down there. But I still need to figure out what the value of n is, so I'm going to go ahead and simplify that. So 9/1 times the value 13/2 is going to equal n. I can't cross cancel, so I'm going to go ahead and multiply straight across. 13 times 9, I'm going to do some side work, that's 27. So that's going to leave me with 117/2 is n. So I'm going to go ahead and substitute that value into the value of n here so I can see what the new fraction is going to look like. So here we go. We have our 9/2 equals n/13. I know the value of n now. The value of n is 117/2. So here is my equivalent fractions. Okay. The ratios are for sure equivalent. Why? Because I multiplied both the numerator and denominator by the same multiplier. In this case, 13 halves. Okay, so for number 3, what I'd like you to do is go ahead and pause the video and try this one by yourself. Okay, so let's see how well you did. We're going to try to find the multiplier between the numbers here. So I'm going to go ahead and use the m for multiplier. So 3 times a value m equals 11. I'm going to go ahead and solve this equation by dividing both sides by 3, leaving me with m equals 11/3. So at this point, I'm going to claim that the constant multiplier is 11/3. Let me just double check to see if this is true. The 3's cross cancel, indeed leaving me with 11, so I can go ahead and say that the multiplier is 11/3. So now that I know that, I can go ahead and multiply 7 by 11/3 to figure out the value of n. So let me go ahead and work that out. Notice, because 7 is a whole number, I went ahead and wrote it as a fraction by putting it over 1. I can't cross cancel, and that's going to leave me with 77/3. Whoops, let's do this real quick. You'll see here 7 times 11/3 is supposed to equal n, so leave the n there. So we're going to be left with 77 thirds equals n. Now that I know this value here, I'm going to go ahead and plug it into my original problem. 3/7 and 11 over n. Well, n is 77 thirds, so I'm going to go ahead and substitute that in. So I know for sure that these two ratios are equivalent. And again, I know that because I multiplied both the numerator and denominator by the same multiplier, which was 11 thirds. Okay, last one like this. I'd like you to once again pause the video and try this one by yourself. Okay, so let's see how well we did. Here you can't really figure out how 5 became n since we don't know the value of n. So we're going to go ahead and do 3 times a value of m is going to equal 2, m being the multiplier that we're trying to figure out. So we're going to do 3m equals 2. To solve for m, we're going to divide both sides by 3. So m is 2 thirds. So at this point, I'm going to claim that the multiplier to get from 3 to 2 is 2 thirds. I'm just going to double check that to see if this is true or not. So this is. So I can confidently say that the multiplier is 2 thirds. And because I know that, I can go ahead and figure out the value of n by multiplying the numerator by 2 thirds. I'm going to work this out. 5 over 1 times 2 thirds is going to give me the value of n. Here I can't cross cancel. So I'll multiply across. 5 times 2 is 10. 1 times 3 is 3, so 10 thirds is n. Now that I know this value here, we can go ahead and substitute it into the very original problem. So 5 thirds and n over 2. We know the value of n is 10 thirds, so I'm going to go ahead and put that there in place of n. So here is our ratios that are equivalent. And again, I know they're equivalent because both the numerator and denominator were multiplied by the same multiplier, which was in this case a 2 thirds. Okay, so for number 5, the instructions are slightly different, just the way that it looks, but it's very similar to what we were doing before. It says for each of the following, they want to A, wanted to find the multiplier, and B, find the value of the variable to create a proportion. So this one's different. Why? In all the other examples, the variable were all on the right side. Now, it's on the left side. So what do we do in that case? Well, in this case, what we want to do is go the reverse. Before we were working our way to the right, meaning we figured out 3 times what is 5. Because x is on this side, what I'm going to do instead is figure out 5 times what multiplier is going to give me 3. So let's go ahead and solve this equation that we've created. 3 equals 5m. We're going to divide both sides by 5. And we're going to claim that the multiplier is 3/5. Now, before I claim that this is indeed the multiplier, let's go ahead and check. How do I check in this case? Well, in this case, since we aren't moving direction to the right, we are moving to the left, I'm actually going to multiply the 5 by the 3/5 to check and see if it does equal 3. And lo and behold, it does. So I'm going to go ahead and stick with my answer that the multiplier is 3/5. So I'm going to multiply the 4 by 3/5 as well and claim that that is x. So let me see what that looks like. X equals 4 over 1 times 3 over 5, which means x equals 12 over 5. So find the value of the variable to create a proportion. I'm going to say x equals 12/5. So the key thing to remember is the direction in which you will be going does matter. So in this case, we worked our way from the right to the left, versus before we were always moving from left to right. So let's take a look at another example. So once again, you're going to find the variables on the left side. So we're not going to want to move towards the right. We're going to reverse it and go to the left. So here I'm going to say 3 times a value, aka the multiplier, is going to give me 7. Let's solve that. 7 equals 3m. We're going to divide both sides by 3, leaving me with the idea that the multiplier may be 7/3. But before I claim that that is my answer, let me just check that real quick. And again, because we're moving backwards, I'm going to multiply this 3 by 7/3 to check to see if it works or not. Here, the 3's cross-cancel, leaving me with 7, so this is true. So I can confidently say this 7/3 is our multiplier. I can go ahead and do the same thing with 8. I'm going to multiply by 7/3 to figure out the value of W. So here, W is 8 times 7/3. So I'm going to say W is 56/3. So in order to make this a proportion, I'm going to say W has to equal 56/3. Now moving on to a word problem. Here it says, number 7, a recipe for 26 rolls calls for 5 tablespoons of butter. At that same rate, how many rolls can you make if you have 8 tablespoons of butter? So there are several ways to get to the answer to this problem. I'm going to show you 2 ways. One way is to set it up as a proportion. Here, we can set it up as 26 rolls calls for 5 tablespoons. And what's going to happen if you have 8 tablespoons? So notice, since it's 8 tablespoons, it's going to belong in the denominator so that it matches up. So here, we don't know this value, so I'm just going to go ahead and call it R to represent rolls. So guess what? This is exactly what we've been doing before, so I'm going to go ahead and solve. So notice here, we want to know what R is, so we're going to actually go to the direction to the right. So we're trying to figure out 5 times what value of M is going to equal 8. So here, 5 times a value of M is going to equal 8. Meaning if I divide both sides by 5, I'm going to claim that the multiplier is 8/5. So I'm going to go ahead and check to see if that works. Multiply that 8/5. Does it work? Yes, it does. So I'm going to go ahead and multiply this by 8/5 as well, since that is my multiplier. So to figure out the number of rolls, I'm going to do 26 times 8/5. And that is going to give me, let's see, 26 times 8. 208/5 rolls, since that is the value of R. Okay, now would it make more sense to write that as a mixed number? Especially in a word problem, I'm going to say yes. So let's go ahead and turn that into a mixed number. So with 8 tablespoons, I'm going to safely say that it's going to make 41 3/5 rolls. Now, is there another way? Yes, you can first start with the rate that they gave you, which was 26 rolls for 5 tablespoons. Okay, they want to know how many rolls you're going to make with 8 tablespoons. So here, you do want your answer to end in rolls. So what you're going to do is you want the tablespoons to cancel out. So I'm going to go ahead and put tablespoons up here. Okay, and I'm going to go ahead and just write it over 1. Why? Because by having tablespoons up here, I know this looks strange, sorry about that, you're going to find the tablespoons eliminate and it's only going to be left with rolls, which is the ending result that I want. So here, you're just going to multiply 26 times 8, which we kind of already did. But I totally forgot what that value was. It was 208. And then 5 times 1 is 5. So guess what? We still end up with the same answer. And again, you might want to turn that into a mixed number so that it makes more sense, especially when it comes to word problems. Okay, so let's take a look at number 8. It takes 16 cups of sugar to make 36 brownies. At this rate, how many brownies can be made with 7 cups of sugar? Okay, so here I'm going to go ahead and show you both ways once again. One way is to first set up a ratio and say, okay, there's 16 cups for 36 brownies. So here you go. And then for the 7 cups of sugar, notice it matches up with cups in the numerator. We don't know how many brownies, so we went ahead and said n number of brownies. So what do you do here? This way we are moving towards the right, so we're going to go ahead and say 16 times a multiplier, m, is going to equal 7. So let's figure out what that multiplier is going to be. We're going to divide both sides by 16, and we're going to be left with m equals 7/16. So that is what I'm going to claim, as the multiplier. Let me check to see if that works out. The answer is yes. So I'm going to go ahead and do the same here and multiply this by 7/16 as well, so that it equals n. So I'm going to go ahead and multiply. I notice I can cross cancel by a factor of 4, leaving me with 63/4 brownies. Now, when you turn that into a mixed number, it will be 15 3/4, which again is going to make more sense when you're answering this in real life. You're going to say it's going to make 15 3/4 brownies. Now, is there another way to solve it? Yes. Let's reread the problem real quick one more time. It says it takes 16 cups of sugar to make 36 brownies. At the same rate, how many brownies can be made with 7 cups of sugar? So they basically want to know how many brownies. Now, knowing what they're asking us for actually helps us set up the initial rate. Because there's two ways to write it. You can write 16 cups over 36 brownies or 36 brownies over 16 cups. Now, you always want to keep in mind the unit that you're trying to end with. Since we want the answer to be in brownies, you do want to put brownies on top. So I am going to put the 36 brownies in the numerator, and I'm going to go ahead and put the 16 cups of sugar in the denominator, and you're going to notice why in a moment. Since I want my units to be in brownies, notice it should be in the numerator. If it's in the denominator, it's not going to be the same, and that's why it's important for you to identify what is the ending unit going to be. Is it going to be in cups or is it going to be in brownies? In this case, since it's brownies, it should be in the numerator. Now, since I don't want cups, I want those units to be eliminated, I'm going to go ahead and put it on top. And we know that there's 7 cups. And you're going to find that the cups eliminate. Now, you're probably wondering, now what do I put here? Simply put a 1. It's a placeholder, and that's it. So now that I've done that, I'm going to go ahead and multiply straight across. Okay? But real quick, I've noticed something. We do have a fraction here that can be reduced, which probably should have been reduced at the very beginning. That was my fault. So let's go ahead and do that right now. 36 and 16 both have a 4 in common, so we're going to turn this into a 9, and we're going to turn this into a 4. So if we multiply across, 9 times 7 is 63, and 4 times 1 is 4. And you're going to notice, since cups are gone, we're just left with brownies over no units at all. So isn't this the exact same answer that we had previously? Yes, except we turned that into a mixed number. So let's do that real quick. So my answer is going to be 15 3/4 brownies will be made with 7 cups of sugar. Okay, last but not least, it says, in a certain recipe, it takes 12 cups of flour to make 108 cookies. At that same rate, how many cookies can be made with 9 cups of flour? So here, what I'm going to do is go ahead and first set it up as a ratio. I went ahead and put the cups in the numerator and cookies in the denominator, like so. Since we are moving towards the right, I'm going to go ahead and say 12 times what multiplier is 9. If I solve this, I'm going to divide both sides by 12, leaving me with m equals 9/12, but I can divide both the numerator and denominator by a factor of 3, leaving me with 3/4. So I'm going to claim that the multiplier is a 3/4. I'm going to go ahead and check to see if this works. Let's see, 12 and 4 have a 4 in common, and 3 times 3 is 9, so that works. So I can confidently say the multiplier is 3/4. So we're going to go ahead and do the same thing here. 108 times 3/4 should give us the amount of cookies. So we're going to do 108 times 3/4 equals the number of cookies. 108 and 4 have a 2 in common from what I can tell, since they're both even. which is going to give us, let's see, 108 divided by 2. Going to give us 54. But wait, I notice both of these are even again, so I can divide one more time. 2 divided by 2 is 1, and 54 divided by 2 is 27. So here I'm technically going to multiply 27 times 3, which is going to give us 81. 1 times 1 is 1, so just 81 equals n. So what does this mean? It means that if I have 9 cups of flour, I'm able to make 81 cookies. So in other words, we're going to replace this n value with a 81. So again, 9 cups of flour will make 81 cookies. But is there another way? Yes. Again, we're going to read it once more, and we're going to figure out what should the final unit be. So it says, in certain recipe, it takes 12 cups of flour to make 108 cookies. At the same rate, how many cookies can be made with 9 cups of flour? So they're asking us how many cookies. So the answer should end in cookies. Since it's going to end in cookies, you do want to place the rate with cookies in the numerator. So we're going to start with 108 cookies in the numerator, and we can go ahead and put the cups of flour in the denominator. Okay, since we want our final unit to be in cookies, I do want the cups to eliminate. So there's a cup in the denominator, so I'm going to put the cups in the numerator. They specifically asked for 9 cups of flour, so I'm going to go ahead and put 9 up here. And this is just a placeholder, so I'm going to put a 1. So here you're going to notice that the cups are going to eliminate. Perfect. I can see between 12 and 9, they do have a 3 in common, so I'm going to divide by 3. And between 108 over 4, I can see that both of them can be divided by 4. I learned that from the previous one. So this is going to become a 1, and let's see, 108 divided by 4. It's going to go in twice. It's going to go in 7 times, so this is 27. So last but not least, I'm going to do 27 cookies times 3, which is going to give us 81 cookies. And that is your answer. So guess what? That concludes the lesson for today. Thank you so much for tuning in, and as always, until next time, bye.